Hello, and a huge welcome to Dr. Sasan Azizian's Java students, and really to anyone who's ready to get a real handle on the Spring framework. We are about to unlock two of its most powerful, most fundamental concepts, inversion of control and dependency injection. Seriously, this is the stuff that separates amateur code from professional code. So let's get right into it. All right, let's start with a problem that I bet feels pretty familiar. You ever write a piece of code, and it works, but then you need to change one little thing, and the whole thing just shatters? It's like all the different parts of your code are super glued together. Well, that's a classic sign of something called tight coupling, and honestly, it's a massive headache for developers. So how in the world do we fix this? How do we untangle that mess? Well, here's our game plan for today. First, we're going to look at why our code gets stuck. Then, we'll introduce the big, brilliant idea that solves it. After that, we'll see exactly how it works under the hood, we'll clear up some terms that people often mix up, and finally, the best part, we'll talk about the new developer superpowers you're about to get. Okay, first up, let's really dig into why our code gets so tangled in the first place. It all boils down to how our objects get all the other things they need to do their jobs. The old school way, the traditional way, is what I like to call the do-it-yourself approach. You know what? Before we even touch a line of Java code, let's use a simple, real-world analogy that is going to make this whole thing just click. Let's imagine your job is to build a car. So in this do-it-yourself world, you're responsible for literally everything. You've got the car's blueprint, sure, but you also have to go out and personally get every single part. Need an engine? You have to stop what you're doing and go find or build an engine. Need a steering wheel? Same story. Yeah, you're in complete control, but it's incredibly slow, it's inefficient, and now your car is permanently stuck with those exact parts you picked. Now, let's flip that. Picture a modern car factory. The car frame moves down an assembly line, and at each station, the exact right part, the engine, the wheels, the doors, is delivered to the worker at the exact right time. The workers don't go hunting for parts. The parts come to them. The control has been completely flipped. You might even say it's been inverted. And that, right there, that assembly line idea, is the perfect way to understand our first big concept. It's a huge shift in how you think about programming, and it is the absolute core principle that the entire Spring framework is built on. It's called inversion of control. So here's the big change. With inversion of control, your code stops being the boss that has to create everything. Instead of your code saying, I need to create a new engine object, it just raises its hand and says, hey, I need an engine to do my job. And the Spring framework, our assembly line manager, hears that request and just delivers a ready-made engine. You give up the boring job of creating things, and in return, you get an incredible amount of flexibility. Okay, that all sounds great in principle, right? But how does the framework actually do it? If IoC is the big idea of the assembly line, how do the parts physically get to the car? Well, that brings us to the mechanism, the how-to. It's called dependency injection. Dependency injection is the pattern that makes inversion of control actually happen. It's the action. It is the robotic arm on the assembly line that grabs the engine and bolts it onto the car. Your object has a dependency that's just another object it needs to function, and the framework literally injects that dependency right where it's needed. No fuss, no muss. And here is what that looks like in real code. Just look at the two side by side. The most important difference. On the right, in the Spring way, the new keyword is just gone. Our report generator isn't hard-coded to a specific CSV exporter anymore. It just declares that it needs one, and Spring takes care of the rest, injecting it for us. It's such a small change in the code, but it's what creates that loose coupling that makes everything so much more flexible. All right, so you'll hear people use IoC and DI like they're the same thing all the time, but they're not. And knowing the difference is actually really important for understanding what's going on. So let's put it all together and make this distinction crystal clear. This table nails it. Just think of it this way. Inversion of control is the what. It's the big idea, the high-level design principle. It's our assembly line concept. Dependency injection is the how. It's the specific pattern, the technique that makes IoC possible. It's the actual act of delivering the parts. You can't have the assembly line without the delivery mechanism, right? DI is the engine that makes the whole IoC principle work. So we've covered the what and the how, but here's the most important question. Why should you care? As a Java developer, what's in it for you? Well, it's about getting some honest-to-goodness developer superpowers. Seriously, when you let Spring handle your objects, your code becomes so much easier to test. As you get into unit testing, you'll see you can just inject a fake object to test one piece in isolation. It's amazing. You can also swap out components like their Lego bricks. Need to export to a PDF instead of a CSV? No problem, just inject a PDF exporter instead. This all leads to code that's more modular, way easier to maintain, and it lets you spend your brainpower on the fun stuff, the actual business logic, not the boring plumbing of creating objects. So if there's one thing to take away, it's this. You are basically outsourcing all the tedious and error-prone work of managing objects to a powerful, expert framework. And what this does is it frees you up to write code that's cleaner, more flexible, and frankly, far more professional. This is how you build things that can grow and change without breaking. You see, mastering this concept isn't just about learning a new feature in a framework. It is about fundamentally changing the way you approach building software. By letting go of that low-level control, you gain a massive amount of freedom to focus on creativity, on problem-solving, on innovation. So the real question to leave you with is, what amazing things are you going to build now?